After our historic map now is on the right position in the world, we can proceed digitizing it and transforming it to a digital version. There are several possibilities we have now. The easiest one would be just simply have the OpenStreetMap in the background and digitize all the points on top of that. Or we can use a freely available image, which we can put our points on and print it, or we can produce it by ourselves. And that's the way we are going to do it now. We'll switch that off and kick it directly out. And in the end, it should look like this. And I will show you where to get all the data to produce something like that and how to digitize the feature from our historical data set. So what we need to produce this nice looking physical map is a so-called digital elevation model, which is describing the landscape by a pixel-based map. I zoom in a little bit more, and now you can see now the single pixels, and every pixel is connected to an altitude. And then QGIS can colorize every pixel according to its altitude, and that will lead to something like this. But where to get the elevation model? Fortunately, that is quite easy. You will go to a service called Earth Explorer, where you have to create an account, which is free, and all the data contained in the system are also free. What you need to do, you have to zoom in to Hispaniola, and then you have to draw a box, or what it's even easier is just to zoom in as close as possible, like this, and press Use Map. And if you zoom out again, you now can see there's a box drawn around the island. Make it smaller by moving these green dots. Make it as tight as possible because we don't need the data covering the sea. That should be fine. Now you go for datasets, and you can now search for SRTM data, and you go for the 1 arcsecond global data, which means 1 arcsecond is 30 meters in real world. So the resolution of the DEM we can derive from those data is 30 meters. So every pixel will be 30 meters in size. And you press it, and it will be directly chosen here. And now you go for results. It will take a little while. And now you can see we have 19 single tiles. And if you want to see where the tiles are, you can press on this footprint. And now you can see which data are hidden behind it. So for example, this one, it's not necessary for us. It's just inside because our polygon cuts it. So we can exclude it. So what we do next, you can press a download button and download them all. There's a little bit of cumbersome process. I would recommend to use a so-called bulk download. You just have to tick this box. I will just take this 3. And now you can go to View Item Basket and Start Order. Now we have to push this button, unfortunately, again. And now you have to choose which file you want to download in which format. And I recommend you to go for the GeoTIFF 1 arcsecond files. Just have to click them, and now you see 3 scenes selected. I don't want to download all 19 again because I already did it. And now you just can type a name for your order or leave it like it is. And you can go for Submit Product Selection. Now it's submitted, and you will receive an email when it's done, and then you can simply download the files all at once. I will save this one and we'll start a new project. and go back to the data, they will look like this. If you open them with an image viewer, you won't see much because they're not made for it. But if you drag them into your QGIS, you can see what's meant by every pixel is describing a certain altitude. It's still not really good for the visualization to understand what is going on, but we can proceed processing them to have a first look. Therefore, first we need to combine them all. So we go to raster and here, and we go to build virtual raster. Now you can click here on the 3 points, select all. You have to take care a little bit. Maybe it already contains other data and you don't want them inside your big raster file. So take a little bit care for it. And then you press 1. And now they're all combined. Take care that the virtual raster now is on top. And what you can do now, go to your layer styling panel. If it's switched off, right mouse button and layer styling panel switched on. And then you can change this value from single band gray to hillshade. And what you can see now is an artificial sun illumination of our elevation model describing all mountains and physical and morphological features of the island. You can see when you zoom in, it will cause some issues, which is caused by the fact this one is just a temporary solution, and if you really want to produce a hillshade, you have to go to raster and to analysis and to hillshade. But we will not do it now because we need to process the data a little bit further. Because one problem we have is that they need to be reprojected. You can see here all our coordinates are in latitude and longitude, means in degrees, minutes and seconds, and we can't work with that. As long as you see here degrees, you might be able to do a little bit with the system, you might get some results, but in the end you will definitely fail with the most things. For example, if you want to put in a scale in it, it won't work because it doesn't know the distances, because it's all based on degrees and minutes. It's projected on a spheroid and not in a 2D projection. So that's the thing we need to do now. Now we need to roll out our data set into a 2D projection. So where to find the 2D projection? That's fortunately quite easy. So we go to our virtual raster set, we go to export and to save as. We will stay with a GeoTIFF. We don't want to create a virtual one, it should be a combined one. We need to give it a file name. And I will call it iti proc for process, and it will call it 32618. And you will see why I call it like this. We'll go to save. And you can see here now it's still set on WS84, so it's a global coordinate system, but we need to select a wheel projection. So therefore we have a big choice, and they're all hidden behind these numbers, and you see there are hundreds and hundreds of different projections, and usually it's quite complicated to figure out which one is good for your region. Therefore I recommend you to use outside of Europe and outside of North America the so-called UTM projection. It's also based on the WS84 where our data projected in when we download them, but that one is a spherical projection. So, and now this one, zone 32N, would be the one I would use in Germany. And if I move one to the right, I would be in the right one for south of Italy or Austria. And now to find the right one for Haiti, it's not so difficult, a little bit playing around. Could be 17. No, it's too far in the west. So maybe we move on one to the right. Yeah, it's half the island, maybe one more. Yeah, that should be fine. So the biggest part of the island is covered. It doesn't matter if it's fully covered. The errors you will get are below centimeters, so that doesn't matter. But what you can do is to use now a coordinate system which is on the other side of the globe, so take care for it a little bit. And that's a very, very important part of using geographical data, to project them in the right coordinate system which describes a certain part of the world. Now you press OK. Oh, yeah, typed 18, so I will also call it 19. And what you haven't seen now, I can change it again. Here you have very strange numbers, and that is somehow degrees. And if I set it now to the 19, now you can see we have meters. And as I said before, every pixel is 30 meters, and the small error we have now in the different values here is caused by the reprojection process. So first thing I want to do is to put it to 30 again, so we keep the best resolution the data set offers, but in the end is a little bit too much for our project, because we want to display a whole island. So you have the possibility to change it. You might go for 100 meters, but in our case it would be a little bit too small. I would go for 50 meters. So the data size will shrink a lot, so it will be much smaller than the full resolution image, but it will still contain the most information we need now for producing a nice map. Of course, if you need more detailed information because you want to produce a map in a different scale, you need better data, and that can be a quite complicated process to get them. Now we will press OK. That will take a while. And now we have our data we projected. First thing to do now, to see how it actually looks like, is to change the coordinate system of our viewport. Therefore, there's a small button here, and you go to this window and you will choose the same system we used now for our reprojection, and it should be on top, otherwise you have to type it in, and in that case it's easy, it's 32619. They all start with 326, and if it's in the southern side of the world, it will be a 5. And now you press OK. And what you now can see, here the coordinate changes from degree to meters. So if I move my cursor, you can see the coordinate in meters. And of course, because here is the border of our zone 19, if you move in this direction, we will go to negative coordinates. That's usually unproblematic. It just can be a problem if you want to use the data in a statistical software like R or SPSS, because they don't like negative values. So you have to find another solution for it. But that will not be our issue now. Now we are going to produce our first hillshade. Now we go to raster, analysis, and hillshade. We will leave everything like it is. What you can set here is the vertical exaggeration. So if you have a really flat landscape, you can set it to a higher value, so you might see the morphology a little bit better. You can set the direction of the light and the altitude of the light, but if you're working on such a big scale, I wouldn't touch it. It might make sense if you work in a very limited area and some valleys might be completely shaded because the sun is coming from the wrong direction, then you can change it. All the rest I would leave like it is. We will produce a temporary file because we're not really going to use it, and I will show you now why. We go to 1. So that is now our result. And now you can see clearly all our landscape morphology. But if you zoom in a little bit, you see all these lines. And you can see they're all small squares. And that's an error caused by the projection. It's a very complicated thing to solve it, but what we can do is to proceed working with it and be fine with the small errors we have, or we filter it and make it a little bit smoother. Unfortunately, that can't be done in QGIS. We need another software, which is fortunately installed within the QGIS installation. The tool is called Saga GIS, and how we proceed with it, I will show you in the next video.